Hello, ladies and gentlemen. Today we're going to look at the sum and difference identities. All right. Here are the sum identities. The sine of alpha plus beta is equal to the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. The cosine of alpha plus beta is equal to the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. The tangent of alpha plus beta is equal to the tangent of alpha plus the tangent of beta divided by 1 minus the tangent of alpha times the tangent of beta. Here are your difference identities. The sine of alpha minus beta is the sine of alpha times cosine of beta minus the cosine of alpha times the sine of beta. The cosine of alpha minus beta is equal to the cosine of alpha times the cosine of beta plus the sine of alpha times the sine of beta. And the tangent of alpha minus beta is the tangent of alpha minus the tangent of beta divided by 1 plus the tangent of alpha times the tangent of beta. Now, if you look at those identities, you can shorten them up and make them look more like you want, or easier to remember anyway. And what I would remember is this way. And by the way, if you want to get rid of the Greek letters, you can as well and use our American letters or the standard letters. The sine of alpha plus or minus beta is the sine of alpha times the cosine of beta plus or minus the cosine of alpha times the sine of beta. All right, notice that the plus or minus is the same in both locations. On the cosine of alpha plus or minus beta, it's the cosine of alpha times the cosine of beta minus plus the sine of alpha times the sine of beta. And notice that the plus or minuses have been inverted, okay? The tangent of alpha plus beta is the tangent of alpha plus beta, or plus or minus, but then on the denominator, the plus or minus has been inverted, and it's 1 plus or minus the tangent of alpha times the tangent of beta. Okay, all right, let's look at using these, all right? And we'll start with example 1, which says find the cosine of 105 degrees using a sum or a difference. Well, I'm going to use a sum, and I'm going to use the fact that 45 degrees plus 60 degrees is equal to 105. So I'm going to rewrite the cosine of 105 as the cosine of 45 degrees plus 60 degrees. All right. And then I'm going to use my sum identity. All right. And the cosine sum says that this is equal to the cosine of alpha, which in this case is 45 degrees. All right. Times the cosine of 60 degrees, all right, and this is going to be minus, because if you look, it's inverted, so we're doing the up top part here, we got to do top part there, the product of the sines. So the sine of 45 degrees times the sine of 60 degrees. Okay. All right, now we know the cosine of 45 degrees is square root 2 over 2, so we'll replace that with the square root 2 over 2. We know that the cosine of 60 is 1/2, so times 1/2 minus, once again, the sine of 45 is the square root of 2 over 2 times the sine of 60 is square root 3 over 2. All right, so square root 3 over 2. So we do each product first before we subtract. The first one is the square root of 2 divided by 4 minus the square root of 6 divided by 4. All right. And now when we simplify that and get our exact answer, the common denominator is 4. The numerator will be the square root of 2 minus the square root of 6. And that is what's called your exact value. All right, and you can approximate that if you have a calculator. I want you to know that immediately. All right, and let's do that real quick. We'll do this with our calculator. First thing is we do see degrees, so we need to be in degree mode. Excuse me. Okay. All right, so go into degree mode. All right, and after you get into degree mode, you could start by just doing the cosine of 105, by the way, because we're going to see what decimal approximate that is right there. There it is. And that is indeed the exact same thing as alpha y1 to get my fraction. Put in my numerator the square root of 2. Be sure to come out from under that before you decrease that by the square root of 6. And then divide that by 4. And you'll see you get exactly the same thing all the way across the board. Okay, so there's example number 1. All right. Let's go to example number 2 next, all right? And it says to use a sum or a difference, okay? Well, what I'm going to do is I'm going to do a difference this time, all right? And I'm going to do pi over 12, let's see, 3 pi over 12, all right? I'm going to think of this as the sine of 3 pi over 12, all right, minus 2 pi over 12. All right, and the reason, because if you subtract these two, you'll go right back to pi over 12. But please understand this. 3 pi over 12 is the same thing as pi over 4, and that's on the unit circle, and that's why I wanted to do that. Minus 2 pi over 12 is the same, simplifies to pi over 6. And now I've got quantities, angles, A and B, that are on the unit circle. And I'm going to use my sine identity. The sine is plus or minus here, plus or minus there. So this would be equal to the sine of the alpha, I'm right here, which is pi over 4, all right, times the cosine of beta, which is pi over 6, all right, and this was a subtraction, which is down, then that's going to be a subtraction as well. And this would be the cosine of alpha, my alpha is pi over 4, all right, times the sine of my beta, which is pi over 6. All right, now I'm going to continue off there from the right down there, and I'm going to say replace the sine of pi over 4 with the square root of 2 over 2, okay. Replace the cosine of pi over 6 with square root of 3 over 2, okay. All right, replace the cosine of pi over 4 with square root of 2 over 2, and replace the sine of pi over 6 with 1/2. All right, and then I'm going to multiply each product. Over here, I get the square root of 6 over 4. Over there, I get the square root of 2 over 4. All right, and now I can combine those into one fraction. All right, the common denominator is 4. The numerator will be this numerator, the square root of 6, minus the other numerator, square root of 2. And that is your exact answer, and you can approximate that if you want. All I'm going to do is show you with the calculator that they are indeed equal, okay? And I'm going to do that right here, but first thing I need to do is to make sure I'm in degree mode, or excuse me, radian mode. So I'm going to go to mode, go to radian, because I have no degree symbols. And I'm going to type in the sine of pi divided by 12, and see that decimal. There's that decimal. That should be the exact same thing as the square root of 6 come out from under that radical decreased by the square root of 2 divided by 4. And let's see if we get the exact same thing. We do, and that way we could double check to make sure everything we've done is indeed correct. Let's move on. Let's go to number 3. All right, on the next page, on number 3, it wants us to do the tangent of a sum of angles, okay? All right, and we have our identity that says that the tangent, and I'm going to write this identity up here on the top, of alpha plus beta is equal to the sum of the tangents, the tangent of alpha plus the tangent of beta, all right, divided by 1, all right, minus the product of the tangents. Okay, so that's the one we're going to use right there to evaluate this, and we would probably be able to do this without our calculator at all, and then check it with our calculator. How's that? So this would be equal to the product of the tangents, so that's the tangent of 3 pi over 4 times the tangent of pi over 6 divided by 1 minus the product of the tangents, 3 pi over 4, and the tangent of pi over 6. Okay, all right. Well, the tangent of 3 pi over 4 is -1. Okay, so -1 plus, all right, the tangent of pi over 6 is the square root of 3 over 3. You can get that off of your unit circle if you forget it, okay? And then we're going to divide that by 1 minus, okay, the product of those two terms in that numerator, -1 times the square root of 3 over 3. All right, so this would be equal to, if I imagine this as being negative 3/3, okay, that's what I like to do. I could write that numerator as a common denominator of 3, and it would be the square root of 3 minus 3 is what I would do, okay? The square root of 3 minus 3 for that numerator, okay? All right, and down below, I'm going to have a negative times a negative is a positive, and a positive times a positive is a positive, so this is going to be plus. And then 1 times the square root of 3 over 3 is simply the square root of 3 over 3. Okay, square root of 3 over 3. All right, now I've got almost a complex fraction. I really need to simplify that denominator, and what I'm going to do is imagine 1 as being 3/3. If this is 3/3, all right, which is 1, all right, my numerator is still the square root of 3 minus 3 over 3. And then my denominator will become a fraction with the common denominator of 3, and it would be the square root of 3 plus 3, okay? And now I've got a complex fraction, one fraction divided by another fraction, and that means I'm going to take the fraction from the numerator, which is the square root of 3 minus 3 over 3, and multiply it times the reciprocal of the fraction in the denominator, which is 3 over the square root of 3 plus 3. Now, this 3 and this 3 will cancel, which would give you the square root of 3 minus 3 divided by the square root of 3 plus 3. Now, of course, you're not allowed to leave that radical in that denominator. So that means that we're going to multiply both the numerator and the denominator by that denominator, which is the square root of 3 plus 3. Square root of 3 plus 3. All right. Up top, the product of the first terms is 3. The product of the outer terms is 3 times the square root of 3. The product of the inner term is negative 3 times the square root of 3. They'll cancel. And then negative 3 times negative 3 is negative 9. Down below, the product of the first terms is 3 plus, oh, wait a minute, that's supposed to be a minus. My fault. I'm sorry. I've got to multiply by the conjugate to get to rationalize that denominator. It wasn't rationalizing. Okay, now let's go back. Okay, up here, that's going to change this slightly. All right, square root of 3 times the square root of 3 is still 3. This is 3 times square root of 3, and that would be minus, oh, that's going to be minus. So that would be minus 6 times the square root of 3. My fault, because there's going to be 2 of those. And then minus 9. Okay, and down here, the outer product and the inner product should cancel, and then this times this is equal to negative 9 as well. So that gives me 3 minus 9, which is negative 6, minus 6 times the square root of 3 over negative 6. All right, and now, okay, let's see what happened here. Let's see, negative 9. Yeah, we're good. Okay. All right. Oh, that should be positive. Oh, that's going to be positive, which means this is positive, which means this should have been positive 12. That's my fault. I'm sorry. That should have been positive 12. And now all of these terms, all the 2 in the numerator and the 1 in the denominator, are divisible by 6. So I'm just going to take this and divide, or by negative 6. I'm going to take 12 and divide it by negative 6. That would give me negative 2. I'm going to take negative 6 times square root of 3 over and divide it by negative 6. That would be positive the square root of 3. All right, there's your work for that. I just made a simple mistake, and I'm sorry. Thank you. All right, now you can check this once again. Make sure you are in radian mode, which I am currently, okay, in radian mode. And if you type in the tangent of, we have a fraction, alpha y1 to get my fraction, 3 pi is my numerator, and 4 is my denominator for alpha, plus we got another fraction for beta. Beta is pi divided by 6. Uh-oh, I got to go to that problem. I didn't get my, oops, hold on one second. That's supposed to be a 6. And up top, oops, not there. Right here, we need to delete, come out of that fraction, and then close it off. So there is the tangent of 3 pi over 4 plus pi over 6. There's the decimal equivalent for that. That should be equal to negative 2 plus the square root of 3. Okay, and as you can see, they are exactly equal. All right, let's go on. Example number 4 says, write the expression, the sine of 40 degrees times the cosine of 130 degrees minus the cosine of 40 degrees times the sine of 135 degrees as the sine, cosine, or tangent of an angle. Well, when I look at that, we got a product of sines of alpha and beta minus the product of the cosine of alpha times the sine of beta. Well, that, to me, looks like it's the sine. It looks like they're using, and I'm going to write the rule over here, the sine of alpha minus beta, all right, is equal to the sine of alpha times the cosine of beta, all right, minus cosine of alpha times the sine of beta, all right. So I've got the right-hand side over here. I've got the sine of 40 degrees times the cosine of 135 degrees minus the cosine of alpha, which is 40 degrees, times the sine of beta, which is 135 degrees. All right. And that means I'm going to bring those alpha and beta over here to the left and put them in. Alpha is 40 degrees. Okay. All right. So 40 degrees minus beta is 135 degrees. All right. And now 40 minus 135 is negative 90. So that could be the same thing as the sine of negative 95 degrees. Now, of course, you wouldn't write negative 95. You'd want to use a positive angle there. So what I'm going to talk about is this. If I take that ray along the positive side of the x-axis and rotate it 90, it'd be here. I need to come 5 more degrees. Well, if that's a 5-degree angle right there, this angle right here, which is my positive angle, is 5 degrees less than 270, which would be 265. So the sine of 265 degrees is one I would want because it's positive. I don't want to leave negative angles lying around. But I will show you that all of these are equal, by the way. All right. If you were to take your calculator, make sure you're in degree mode, which I'm not. All right. If I go to degree mode and I type in the original expression, the sine of 40 degrees, be sure you close that off before you multiply that by the cosine of 135, okay? Minus the cosine of 40 degrees, close that off, and then times the sine of 135 degrees. You will get that quantity right there. Well, that should be the same thing as the sine of negative 90, well, not 94, 95 degrees, if we've done everything correctly. And as you can see, it is. But it should also be the same thing as the sine of 265 degrees. And I'm sure you can see using your calculator that it is as well. Okay. All right. Let's turn the page on the notes, please, and go to the next page. Next page, we have example number 5, and it says, find the exact value of the cosine of pi over 16 times cosine of 3 pi over 16 minus the sine of pi over 16 times the sine of 3 pi over 16. Well, that looks to me like it's the cosine of the sum of two angles, okay? Because we know that the cosine of alpha plus beta is equal to the product of the cosines of alpha and beta minus the product of the sines of alpha and beta. That's the rule that you're using here, okay? We have that right-hand side, the cosine of pi over 16 times the cosine of 3 pi over 16 minus the sine of alpha, which is pi over 16, times the sine of beta, which is 3 pi over 16. All right, and then when we bring alpha, this is alpha, and beta right here, when we bring them over and do the cosine of alpha pi over 16 plus beta 3 pi over 16, we can then simplify that to the cosine of, let's go ahead and do this. We'll probably get this done easy. That's 4 pi over 16, but that reduces to pi over 4. All right, and I know the cosine of pi over 4 is simply the square root of 2 over 2. All right, And I'll leave that check up to you. You can probably check and make sure that's right. I'm pretty sure it is. All right. Any questions? No? All right, we'll move on. Sorry about that. Just habit. Example 6 says, write the cosine of the arc sine of square root of 3 over 2 plus the arc cosine of x as an algebraic expression of x that does not involve a trigonometric function, okay? Well, first thing I'm going to do is say, oh, all right, well, the cosine of alpha plus beta is equal to, and I'm going to use my identity, it's the product of the cosines, all right, minus the product of the sines. All right, so here we go. All right, so I've got the cosine, the arc inverse. Well, if we've got this angle here, all right, and we know that, I'm going to sketch that angle. The inverse sine is defined in the first and fourth quadrants. That's positive, so it'd be in the first quadrant. So that angle is up here in the first quadrant. We'll call that angle theta for a minute. And what do we know for that? We know the opposite leg is the square root of 3, and the adjacent leg is 2, okay? All right, and I'm going to go ahead and find that other leg real quick. Square that is 3. Square that is 4, subtract is 1, square root of 1 is 1, so this leg is 1, okay? All right, and now I can find the sine, the cosine, and tangent of this angle. Let's go ahead and do the sine and the cosine, because we're going to need one or the other. We're going to need both, okay? All right, we've the sine. Let's do the sine. The sine, oh, we've got that already. They told us. The sine of this theta here, or alpha, that's one. This is alpha, by the way. Let's use alpha. The sine of alpha is, as they told us, the square root of 3 over 2. The cosine of alpha is, cosine is the adjacent leg 1 divided by the hypotenuse. So there's that one. All right, now let's talk about B for just a moment. If we're talking about angle B, all right, the inverse cosine is defined in the first and the second quadrants. It would be positive in the first quadrant. Okay, so we'll put beta. Let's put a beta right here. I probably should have put, instead of theta, a there. We'll put beta here. All right, we know that the cosine is x. Well, if you make it a fraction, that's x, which is the adjacent leg, divided by the hypotenuse, which is 1. And then if I do 1 squared is 1 minus x squared and take the square root of that, I'll get this side over here. 1 minus x squared, or the square root of 1 minus x squared. Okay, using my Pythagorean theorem, by the way. All right, now for this one, we already know the cosine of beta is x. What about the sine of beta? Because we're going to need it as well. The sine of beta is equal to the opposite leg, which is the square root of 1 minus x squared, divided by 1, which is just the square root of 1 minus x squared. I'm not even going to write that down. So now I'm going to bring these four quantities and put it into the right side of this identity. All right, the cosine of A is 1/2. The cosine of B is x, so we're multiplying those. Then we're going to subtract the product of the sines. The sine of A is a square root of 3 over 2. And the sine of angle B is the square root of 1 minus x squared. Okay, all right. Now we can simplify. Let's do this. First ratio is x divided by 2. The second ratio is the square root of, when you're doing square root times square root, you can just multiply the radicands. And if I did 3 times 1 minus x squared, that would be 3 minus 3x squared. And then divide that by the product of the two denominators, which would be 2. All right, those have the same denominator, so I'm going to go ahead and combine them into one ratio. Okay, all right, and when I do, I would have x minus the square root of 3 minus 3x squared as my numerator and 2 as my common denominator. And I have written the cosine of the arc sine of the square root of 3 over 2 plus the arc cosine of x as an algebraic expression of x that does not involve any trigonometric function. All right, let's turn the page. Let's go to example number 7. Example number 7 says, given the sine of angle A is 5/13, where the domain of A is between pi over 2 and pi, and the cosine of negative 3/5, the cosine of B is equal to negative 3/5, where the domain of B is from pi to 3 pi over 2. Find the sine of A minus B and the cosecant of A minus B. Okay, well, let's start first of all with angle A. All right, I'm going to sketch angle A. They tell me it's between pi over 2, which is up here, and pi, which is over here. Well, that means it's over in the second quadrant. All right, so I'm going to draw a right triangle over second quadrant. There's my reference angle theta, or actually this one's alpha. Let's put it as alpha. There's my reference angle alpha. And what do I know for this angle? I know the sine, which is the opposite leg, 5, divided by the hypotenuse, 13. Now, I've memorized my whole 5, 12, 13 Pythagorean triple, and I don't have to do that Pythagorean theorem work. If you didn't, you'd have to do the 13 squared minus 5 squared. You take square root of it, you still get 12. All right. Now, I already knew the sine of this angle was equal to 5/13. Now I'm going to find the cosine. Well, I know that in the second quadrant, the x-coordinate's the cosine, and it's negative 12/13. Okay? All right, so there's the cosine of that angle. Now I'm going to sketch angle B. Okay. Angle B, they tell me, is between pi, which is over here at 180, and 3 pi over 2, or 1.5 pi, which is at 270. All right, and that means it's down here in the third quadrant. So I'm going to draw my reference angle, and I'm going to put beta right there for that reference angle. Okay, now what do I know about beta? I know that the cosine is negative. Well, I knew that already. And I know the cosine is negative 3/5. So cosine is the adjacent 3 divided by the hypotenuse. That's the 3, 4, 5 Pythagorean triple. So that leg has to be 4. Okay, well, I already knew the cosine of beta was, as they told me, negative 3/5. Now I want the sine of beta. All right, the sine of beta is going to be a negative because that's a y-coordinate, and the y-coordinates are negative in that third quadrant, okay? And sine is opposite, so negative 4/5 is the sine of beta. Okay, now we want to first find the sine of alpha minus beta. By the way, the reciprocal of the sine is the cosecant, so if I can find this sine, to get the cosecant, all I got to do is reciprocate it to get the cosecant. So let's find the sine of alpha minus beta. And if you use your identity, the sine of alpha minus beta is the sine of alpha times the cosine of beta minus the cosine of beta, all right, times the sine of alpha. All right, here we go. The sine of alpha is right here, 5/13. Okay, so that first factor is 5/13. The cosine of beta is negative 3/5 minus the cosine of beta is, whoa, hold on. Cosine of beta is still negative 3. This should be cosine of alpha, my fault. Cosine of alpha, and this should be beta, my fault. I wrote down the wrong identity, I apologize. Okay, all right, moving on. So 5/13 times negative 3/5, okay, minus the cosine of alpha is negative 12/13 times the sine of beta is negative 4/5. Okay, now let's do these two products before we subtract them. All right, those two 5's cancel, so that's negative 3/13 minus, let's see, I don't see anything canceling over there, so we're just going to take a negative times a negative is a positive. It's going to be a negative, and then 12 times 4 is 48, and then 5 times 13 is 65. Okay, so there is your products, all right? And now the common denominator is 65. All right, so that second fraction is fine. We'll leave it alone for a minute. All right, we've got to multiply this by 5. If we multiply this denominator, 13, by 5, we got to multiply that by 5, which would mean negative 15 over 65 is the same thing as negative 3/13, okay? And now we got two fractions with the same denominator, namely 65. We can combine them into one by taking this first numerator, negative 15, and subtracting that second denominator, 48, and that would give us negative 63 divided by 65. Okay? All right, and you could check this with the calculator as well. All right. I'm going to show you how to do that real quick. If you want to check this with your calculator, this is how you could do that, I believe. Should work for us. All right. I'm going to type in the inverse sine of 5/13, 5 divided by 13. All right. And now there's that angle. And by the way, I probably should have done this in radians because I don't see degrees anywhere. So I'm going to do that real quick. I'm going to go into mode and go into radian mode, if you don't mind. All right, and then pull that back up again and get that angle in radians. So there is the angle A in radians, by the way. Okay, all right. And now I'm going to go over here to angle B. Oh, actually, let's store that. So let's store that angle in A. So alpha A, all right. And now that angle in radians is stored in the memory where the variable A is, capital A. All right. I'm going to hit clear, and then I'm going to go find angle B. All right. The inverse cosine of angle B is -3 divided by 5. Okay. And there's angle B in radians. All right, I'm going to store that in alpha B, and there's that answer right there. And now I'm going to type in what I was looking for, all right, which was I'm looking for the sine of alpha minus beta. All right, so the sine of alpha minus beta should be that quantity right there. Well, that should be the exact same thing as -63/65. And you can either hit math, enter and get it to convert that for you, or you could just type in -63 divided by 65, and you'll see you get the same decimal all the way across the board. Okay, now there was one more thing about this problem that we did not do, and because we wanted two answers here. We wanted the sine of alpha minus beta, which we just found, okay? We also want the cosecant of alpha minus beta. Well, the cosecant of alpha minus beta is the reciprocal, which is 65 over -63. And now we're finished with that problem. Okay, all right, let's go down to the last one we're going to do today. All right, number 8 says find all solutions to the equation the sine of x plus pi over 3 plus the sine of x minus pi over 3 is equal to 1. Okay, well, this is a sum of alpha and beta. This is a difference of alpha and beta. The same two, alpha and beta, because alpha is x and beta is pi over 3. Okay, so what we will do is we'll use the sum difference, the sum formula to write the identity to write this as a product, as an expression involving sine of x and alpha and beta, and then use the difference identity on this one, and then we'll see what we can do about solving it. Okay, so the sum of alpha and beta, alpha plus beta, all right, is going to be equal to the sine of alpha, which in this case is x, times the cosine of beta, in this case beta is pi over 3, okay, plus the cosine of alpha times the sine of beta. All right, that's all from this first term, okay? All right, now we add to separate that term from the second, and the second term is the sine of a minus b, all right? And that's the sine of a, well, a's x, oops, that's an x, all right, times the cosine of beta, which is pi over 3, all right, if it's plus here, a minus here, it's going to be a minus over there, all right? And it's going to be the cosine of x times the sine of pi over 3. And then that's still going to equal 1. Okay, all right. Now, when we look at that, I see that this term, the cosine of x times the sine of pi over 3, and this term are opposites. They will cancel each other, okay? And I also see that these are the same, okay? Which means I'm going to combine those two terms into one and rewrite that plus that as 2 times the sine of x times the cosine of pi over 3. I don't want to write that, you know why, but I will. And that still has to equal 1, doesn't it? Okay. All right. The cosine of pi over 3 is 1/2. By the way, that's why I didn't want to do that. So 2 times the sine of x times 1/2 still equals 1. 2 times 1/2 is 1. And 1 times the sine of x means that the sine of x is equal to 1. Okay, and there's only one place on the unit circle for which the sine of x is equal to 1/2, and that's at pi over 2. All right, now did it want all of the solutions or just the ones from 0 to 2 pi? Well, the key word there is all. So what we have to do is to add 2 pi in to that quantity, and that will give you all possible solutions for that equation. If you have any questions, please call me, show up in a Google Meet, email me, whatever you can do to get in touch with me. Good luck doing your work. Have a good day. Bye.